In this video, we're going to take a look at writing functions using PLpgSQL. However, when it comes to writing functions, you should prefer to use SQL if possible. And the reason why is because the SQL profiler can actually inline and optimize SQL function use. When you use any of the other programming languages to write functions, the profiler can't perform any optimizations. Having said that, there are times when the logic that you want to express is too complex, or you have a multi-step process that lends itself more to looping, if statements, and variables. Functionality that only exists in PLpgSQL. Let's explore the different parts of a PLpgSQL function. The function header starts off just the same as with a SQL function. So it starts with create or replace function, a return statement. We define that we're using the PLpgSQL language. It's in the body of the function, however, that things change. PLpgSQL supports variables, and so has an optional section where you get to declare all the variables that you're going to use in the body. We list all those variables in a section under the declare keyword. After declaring all the variables that you're going to use, the body of the function then lives within a begin and end declaration. You can have multiple statements inside this body, each ending with a semicolon. Let's write an extremely simple function that just increments a variable. We'll call our variable n, and it's going to be of type int, and we'll initialize it with the value of 1. And we want our function to return n plus 1. Let's now create this function, and let's make use of it now. Pretty simple. You can also list any constants that you're using in your function within that declare section. Let's now just write a simple function which will calculate the area of a circle, given the radius as a parameter. You might remember that the area of a circle is defined as pi r squared, so we'll have a constant to represent pi. Let's write this function now. The single parameter is r, which is the radius of the circle. Instead of returning int, we're going to return a numeric. Let's create a constant called pi. We use the constant keyword to indicate this is a constant, and it's of type numeric. I'll just put pi to 5 decimal places. And now let's return pi r squared. Let's create this function, and now let's make use of it. We'll test it out: a circle of radius 1, circle of radius 2, circle of radius 3. So that looks like that works correctly. PLpgSQL also supports if statements. Let's create another new function now called circle area description. And what it will do is just calculate the area of a circle as this function does currently, and then return a description. If the area of the circle is less than 20, we'll return the text small circle, and if the area of the circle is greater than or equal to 20, we'll return big circle. So we'll now call our function circle area description. It's not going to return a numeric anymore, it will return text. We'll create a variable to store the area of the circle after it gets calculated. And that's of type numeric. Now let's use an if statement to check the area of that circle and return some appropriate text. Okay, let's go ahead and create this function now. Now let's make use of it. When the radius is 1, it's a small circle. Still a small circle. Now let's bump that radius up to 5. It's a big circle. So that's how you can use if statements in PLpgSQL. PLpgSQL also supports looping. It's got all the kinds of loops that you would be familiar with if you've worked with a programming language before. For loops, while loops, and looping over a set of records like the results of a query. Let's look at how you can use the for loop to loop a fixed number of times. To demonstrate that, I'll write a function called sum to n, which takes n as a parameter and sums up all the numbers from 1 to n. You can actually calculate that with a simple formula, but for demonstration purposes, we'll sum up and return that result with a for loop. We'll call our function sum to n. It's going to take n as the parameter. It's going to return an integer. Let's clear out that previous function. We're going to have one variable called total, which stores the sum as we're counting. And we'll initialize that with a value of 0. Within the body of our function, we'll now use a for loop. When you're using a for loop, you can actually introduce a new variable, which will exist only for the scope of the for loop. So this is going to create a for loop that has a variable called counter that starts at 1 and goes all the way up to n. We then write loop and end loop. Within that for loop, what we want to do is add counter to the total. And then finally, before the function ends, we'll return the total. So to use this function, you pass in n, and what it will return is the sum of numbers from 1 to n. It uses a for loop to calculate that sum, and an internal total variable to keep track of the sum as it's counting. Let's create that function now. And now let's make use of that function. Try it with 1. Returns 1, that's correct. Let's try it with 10. 55, that's correct. The sum of 1 to 10 is 55. And let's try it with 1000, which I know to be correct as well. So that's how you use a for loop. You can incorporate standard SQL queries into your PLpgSQL functions too. For example, if you want to store the results of a single valued query into a variable, you can do that with a select into statement. Just for demonstration purposes, let's change this function to get n from the number of customers in the database. So rather than receiving n as an argument to the function, n will be calculated to be the number of customers in the customer table. Before we go ahead though, let's first drop this function. The reason why I dropped the function first is because when you change the arguments of a function, if you attempt to replace it, it won't work. The definition of the function has changed. Using create or replace only works when you're changing the body of the function. If you change the header, like the parameters, you need to drop the function first and then recreate it. Okay, so we've dropped the function sum to n. Now let's change the definition of the function. Instead, what we're going to do is obtain n within the function from the results of a query. Let's declare a variable to store that value. We don't need to initialize it because it's going to get initialized from the query. The query will be just selecting the count from the customer table. And we want to store the result in n, which we can simply do by writing into n. So this function now, sum to n, will store the number of customers in the customer table in n, and then it will perform a sum from 1 to n and return the total value. Let's create this function now and make use of it. We obtain the value 179,700. There are 599 customers in the customer table. If you sum from 1 to 599, this will be the value you get, so it's correct. Though it's not a particularly useful function. In the challenge exercises for this chapter, we'll also get a chance to look at looping over the results of a query. So this has been a quick crash course introduction to PLpgSQL. Of course, you could spend a great deal of more time here, learning the ins and outs of what is a fully fledged programming language. As I mentioned at the beginning of this video though, As much as possible, you should seek to write your functions using SQL and think in terms of set operations, and only resort to PLpgSQL when things become more complex than you can handle with just SQL.